23, 76 called Spencer integers. So we are giving a positive integer. So we're going to call a positive integer Spencer if all of its digits are distinct. So giving a positive integer n, we're going to return the number of Spencer integers that belong to the interval 1 to n. So 1 and n is both included. So how can we solve this problem easily? So if some problem in Leetcode or in others, it is about the called Spencer integers or called how many of integers, normally this is going to be a digit DP problem. So for the digit DP problem, basically it is a counting problem. We want to count how many of them. Yeah. But each of the digit, it is dependent on the previous digit. So for example, for this example 20, so for example, if my first digit is 1, so what's going to be the next digit? It can be 0, yeah, it can be 1, it can be anything else, or it can be 9, yeah. So if the first digit is fixed, it is 1, so it can be 0 to 9. So what if the first digit, there's no first digit, yeah, and it is not 0 because from the question, it is from the description, the 0 is not included because we don't have such cases of 0, 1 or 0, 0. We don't have such cases, so we will not count that. Yeah. So this means we're gonna have a setting. So for the first digit, if it is not taken, yeah. So if this first digit is not taken, what's gonna be the second digit? It's gonna be from 0, 1, and something to 9. Yeah. This is another case. Yeah. The first digit is taken or not taken. But if it is taken, if it is not to the limit, because for this digit the limit is 2, so if it is not up to the limit, it is 1, we're gonna have 10 different cases. If it is not taken, we also have 10 different cases. Yeah, but we need to avoid that. Currently we give this one, but we need to avoid this one because according to the description, this one should not be be included. So this means there are going to be 9 different cases. Yeah, and for this example, it's going to be 10 different cases. Yeah, but 0 is also not included because we're going to count it from 1 to 20. We're going to count it from 1 to n. Yeah. So if 0 is not included, what are we going to do? We're going to exclude this 0. So this means if it is 1, we're going to have 8 different cases. If there's nothing, we're going to have 10 different cases. So what about another case is 2? So this is the limit. So if it is 2, how many different cases? We can choose a 0, of course. Can we choose 1? No, because it's going to be more than 20. So there's one case. So 1 plus 8 plus 10, it's going to be 19 different cases. Yeah. So this is the idea how we can use dynamic programming to solve the problem, because all the next digit is dependent on the previous digit. So if the previous digit is 1, so we have 8 different cases. If the previous digit is nothing, there's no previous digit, we're going to have 10 different cases. So if the previous digit is the limit number, I mean the biggest number, so we're going to have only 1 different cases. Yeah. This means we can only choose a 0. So this 0 going to be the int of this digit. We're going to choose an integer of this digit. Yeah. So first of all, we're going to turn this number into a string, of n, and then we're going to directly use the DFS with memorization. So this is the dynamic programming to solve the problem. Yeah. Now we are going to define the dynamic programming. How can we define it? Let me put it here. Yeah. So we're gonna define. Yeah, I cannot find. Yeah, I cannot go back. Let me. Yeah. Yeah. But now we need to define this dynamic programming. So first of all, we're going to turn this integer into a string, and then we're going to use a dynamic programming. So I'm going to define a f function. Yeah. So I'm going to explain each of the definitions because basically this is a template. So I'm going to define index I. So first of all, we're gonna turn the string into turn the integer into a string. So currently we have the string like 20 to 0. Yeah. So this I is from the index 0 and then to index 1 and then to index 2. Yeah, so if this I equals to 2, it means the length of the string. So basically we're gonna have a return. But this return is dependent on the previous digit. If there's a digit at the previous, if there's a previous digit, so definitely we're gonna return a 1. But if there's nothing, so we're gonna return a 0, because at this position there's nothing, we didn't choose anything. At this position we didn't choose anything, so we're gonna return a 0. Yeah. And for this problem, we are also going to check the distinct digit. So this means we're gonna need a mask. I'm gonna explain the mask later. And we also need the isLimit. This isLimit is for checking for our problem if it is a 2 for this digit, or if it is a 0, if it is a 2 or 1 or nothing. Yeah. If it is a 2, it means it is a limit. This means if it is a 2, we can only choose a 0. So this is why we're gonna use isLimit. And we also need to use isNumber. So if it is not taken like this, we're gonna choose isNumber. Yeah, isLimit is for the previous one, and isNumber is also used for the previous one. Yeah. So if I equal to the length of the string, so we're gonna return an integer of isNumber. Yeah. So this means the previously, if it is not number like this one and this one, for example 1, so we're gonna return a 0. So if this is a number, maybe we're gonna choose a 2. Maybe next one also a number, we're gonna choose a 0. Yeah. If this is a number, definitely the next one must be a number, because we already choose a number. Yeah. So if this is not a number, maybe the next one we're gonna choose a number. Yeah. So this is the property of isNumber, isNum. Yeah. So currently, if it is not a num like this, so definitely we're gonna return 0. If it is a num like this or this, so we're gonna return a 1. Now we're gonna start the DFS. So we're gonna check. We're gonna set a result to be 0. So if not is num. So yeah, this means if the previous one is not a number, so we're gonna start the DFS. So the result gonna equal to gonna equal to the DFS with I plus 1. And with the mask, we will not change the mask at the moment, because we're gonna jump to the next digit. Yeah. And its limit gonna be a false, because we didn't choose anything. Yeah, this means there's no limit at the moment. And its number, because we didn't choose number, so its number gonna be a false. Yeah. Now, as we are going to choose some digit like so for the first digit, if it is it can be nothing, or it can be 1, or it can be 2. But if it is something, so the next digit, it can be something else. Yeah. So this means for each of the positions, we need to control. Let me think. We need to control the lowest number and the highest number. So we're gonna set a low and high to check what's gonna be the lowest number and what's gonna be the highest number. So first of all, let's just check the lowest number. Yeah. So for the lowest number, it can be 0, or it can be 1. Yeah. So if it's number, yeah. So if the previous one is a number, so the lowest must be 0. So for example, if the previous one, so for example, this is the previous one, this is a 1. Yeah, so for the next number, it can be 0. This is going to be the lowest number. Yeah, but if the previous one is nothing, so the lowest is going to be 1. Yeah. So else it's going to be 1. And now let's just check the highest number for this digit. So the highest number can be integer of si if it's limit. Yeah, if this is a limit, we're gonna choose the integer of si. If it is not, we're gonna choose a 9. Let me just explain it. Yeah. So for the highest, so for this 2, so for example, if we choose limit, this is limit because 2 is the highest number. Yes. So 2 is the limit. So we're gonna, for the next digit, we're gonna choose the integer of si. It means we definitely for the highest integer we're gonna choose a 0. Yeah, but what if the previous integer is 1? So if it is 1 is not limit because the limit is 2. Yeah, so if we choose 1, it means the highest number we're gonna choose 9, because if it is 1 we're gonna choose 0 to 9. Yeah, definitely we don't want to choose 1 because this will be controlled inside the mask. Here we will not control it. Yeah. Now we're gonna find the distinct integers, and we find all the possible cases. So we're gonna use a for loop. So for any digit in range from the low to high plus 1, we're gonna have a check if there's a duplicate or not. Yeah. Now it comes into the use of the mask. So this mask is used to check if any digit we want to use. So the mask is basically 2 to the power of 10. Basically we have 10 digits, so for each of the positions, so for example, let me just use an example. So this is 0, 1, 2, 3, 4, 5, and 6. Yeah. So for example, currently, if we were to choose number 2, yeah, because currently we're gonna set the mask 0. If it is not taken, this means at this position number 2, 0, 1, 2, at the position 2, we're gonna take a digit, and we're gonna run the DFS. Yeah, if it is taken, we're gonna not choose this number. So this way we can avoid the duplicate. Maybe this time we're gonna choose the number 2, and next time we're gonna choose the number 3, or maybe next time we're gonna choose the number 4. But definitely for the next time we cannot choose 2, 3, 4 because it is already taken. So this is why we're gonna use a mask, just to avoid the duplicate, just to find all the distinct digits. Yeah. Now we're gonna check this mask. Yeah. So if we're gonna use mask, write shift with a D digit and 1. If it is equal to 0, so this means definitely it is not taken. So we're gonna update it to the result. So result gonna plus equal to f here with I plus 1 to the next digit, and here we're gonna do something about the mask. Yeah. So here we're gonna use the mask and add. We want to add this digit inside. We want to put this digit inside. Yeah. So it's gonna be 1 with left shift with D digit. Yeah. So this is one we're gonna left shift with D digit, and we're gonna put this digit inside the mask. Yeah. And the next one is gonna be the is limit. So from the beginning, we're gonna set this is limit to true. Yeah, this is because for each of the time this is limit gonna be used to check if we can if the next number gonna be the highest number. If we set this is limited to false, so here basically we cannot use it because for each of the time it's going to be false. So here may be a true. So this is just a setting from the beginning. We want to make it to be true. And if this is limited to true, next we can easily to check if this number is the limit. So if this number, so for example, is 2, now we're gonna use a 2 add. We're gonna use a 2 add this number. Add this boolean value, it is true, so it's going to be true. So if we set it to false, so if even if this is a limit, it's going to be a false. Yeah, because we're gonna choose this element is limit from the left to the right. So for example, if it is 2, 1, 1, if we have a 2, 1, so it's gonna still be true. Yeah. So this is why from the beginning we want to set it to true. It is not just one digit. It is all the prefix digit, all the previous digit to 1. So this is why we're gonna set it to true. So here we're gonna use is limit, and we're gonna check this digit equal to high or not. If it is equal to high, so definitely, if this is limit is true, so it's gonna be true. Yeah. But here, because we didn't choose any number. So here there's no is limit. Yeah, because we didn't choose any number. So for example, our target is 1, 2, 4. So for the first position, if we didn't choose any digit, this is empty, right? Now we need to control. There's no limit. So this means we can choose all the numbers from 1 to 99. Yeah. So this is why here is a false. Yeah, because there's no limit, we can choose any numbers. Yeah, otherwise we're gonna make mistake. Yeah, let me just check if everything is okay. This is low. Yeah, everything seems okay. Yeah, because in this way definitely we didn't choose any number 0, because 0 is not included, and in our code there's no 0. Yeah, if the previous one is no num, if there's no num, so we're gonna count it as 0 instead of 1. Definitely we didn't count this 0 in our coding. Yeah, because if it's num, the previous one must be a num. Yeah. If it is not a num, we will not count it. Yeah. So currently, for example, this is not a num, and here we want to choose a num. Yeah. If it is not num, we're gonna choose 1. Definitely, we will not choose 0. And then we just avoid the duplicate. We avoid the duplicate. Yeah. We're gonna choose 1 to. We're gonna choose 1 to 9. Yeah. So there are only 9 digits instead of 0. Yeah, so this is how we control the low. Yeah, if it is num, we're gonna choose 0. If there is no num, definitely we're gonna choose 1. Yeah, this means we never choose a 0. Even there's a 1 digit, we're gonna choose 1. Yeah. So this is for the is limit, and now let's just check is num. Because we've already chosen the num, so is num gonna be true. Yeah. So finally, we're gonna return the result, and we're gonna call the f function. So it's going to be starting from index 0, the mask going to be 0, and the is limit, as I explained earlier, we're going to set it to true, and it's num. Yeah, from the beginning we didn't set any nums, so we're going to set it on true false, and then we're going to decide if we wanted to choose a num or not. Yeah. I use the DFS, it should be f. Yeah, now as you can see, it works. Yeah, so this is the magic. It seems that everything is so hard. Actually, it is not, because basically this is just a template, and everything is just a template because it depended on the different problems. So for us, we are going to check the special integers. It means the distinct integers. That is why we use a mask. If we are not going to check the special integers, definitely we can also remove this mask. It is also okay. Yeah, and this is limit, definitely we're gonna use, because we're gonna choose a number gonna be less than and equal to this number n. And it's num because there's no 0, 0 or 0, 1, so definitely we want to check the previous one is a num or not. We want to avoid the duplicate of such cases. Yeah, so this is just a template problem. Now let me just submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. So normally for all the digit DP problem, we're gonna use a DFS with memorization to solve it, and because the time complexity is okay. Now let's just analyze the time complexity. And for this I, it depended on the length of the string, as the length of the string n gonna be 10 to the power of 9. It is a 9 or 10 digit, so we're gonna use 9. So for this I. And for this mask, we can also use a 2 to the power of 9 or 2 to the power of 10. It is okay. And its limit and its num just times 2 and times 2. So basically, this is gonna be yeah. So the length is gonna be 9 or 10. Let's just use 10. 10 times 2 to the power of 12. 2 to the power of 12 is basically 1000 or 4000. So 4000 times 10. So basically it is 4 times 10 to the power of 4. So that is why it's so fast. So this is why we're gonna use digit DP to solve the problem. Thank you for watching. I think that's all about it. See you next time.